Okay, so here we're being asked to graph the following rational functions and then answer the inequality. So fx is 2x add 2 over x minus 3. I'm going to put that in my calculator as y1. You can see I've already done it. And g of x, negative 1 over x minus 2, I'm going to put that as y2 in my calculator. If you look at where the cursor is on the calculator, where it's flashing, there, if I just go there and press enter, I can make that line look different. So I'm going to make y2, which is g of x, look bold. All right, let's go to a standard zoom and have a look at the graph. Okay, so you can see f of x is the light one, g of x is the bold one. Right, so to begin with, we've got f of x on top until we get to a place where the two graphs intersect. So we need to find that intersection. So we're going to calculate the intersection. And it automatically is on y1, tells us that in the top left corner. So we press enter, and then it tells us now we're on y2, second curve. Let's just press enter. And we move our cursor over, and we're going to guess around here somewhere. Okay, so this is telling us now that we have an intersection at x equals negative 1.64. We'll just do three significant figures. All right, let's just do that again, because it looks like the two graphs cross over down here somewhere. So, second, calculate the intersection, number 5. Again, first curve, enter, second curve, enter. But this time, when we do our guess, if I move this along, have a look at where the cursor is going. I don't want to be on that part of the function that goes up really big. I want to make sure I move across. Yeah, there I am. So I'm here. I'm around where the two graphs intersect. That's what I'm trying to find. So press enter. There we are. Second intersection when x equals 2.14. All right. When we hit an intersection, that function is going to go from being really big to really small. So that's also going to be a place where whichever one's on top, f of x or g of x, is going to change. So I need to work out any vertical asymptotes. Okay. Now, graphically, it's quite hard to find them. You can see roughly where they are. One useful thing to do is sometimes if you go to a table, you can see there's an asymptote for y1 where it says error, so where that function doesn't exist. And for y2, it's at 2. So those are my vertical asymptotes. So when x equals 2 and when x equals 3, there will be an asymptote. We can get that quite simply from the algebra as well. The values of x that mean we're dividing by 0 and therefore the function doesn't exist. All right, let's go back and just have our graph up there. All right, so these are our important, we call our critical points. I'm just going to draw like a number line going along here. Oh, ignore that little bit. Let's get rid of it. Oh, okay, and I'm going to put on there all of the critical points. So the furthest one back was the negative 1.64, and then I had, what was next? Next is 2. It's not done to scale at all, as you can see. Then we've got 2.14, and then we've got 3. Okay, those are my points where it changes. So I start off over here, and I want to know when f of x is less than g of x. So to start with, f of x is on top. So we say no here. No, f of x is not less than g of x. And then it will be until I get to 2. At 2, g of x goes from being really small to being, from being really big to really small. So in between 2 and 2.14, we're going to have no. Here we're going to have yes. So between 2.14 and 3, so before I get to this 3, this point here, this graph is really low down, which means that this one, g of x, is on top, and f of x is less than g of x. And then it's the obvious one again is when I get to the end, we can say no. You can clearly see that f of x is clearly not less than g of x. It's lower. So finally, all I need to do is write out my solution. So negative 1.64 x2. Okay, do I need, so I'm going to say when x is bigger than that and less than that. And will it be equal to? No, because the function, the question says when is f of x less than g of x, not less than or equal to. All right, so we can do that. And then the other part is from 2.14. Okay, so when that's less than x, when x is less than 3. So there is my solution written in 2 parts because there's 2 intervals that satisfy that inequality.